Hello, everyone. Today we're going to be going over the MATLAB workshop today for free. And so here's our social media platforms as always. And this week you can see we're going to be going over how to operate MATLAB. And so MATLAB stands for Matrix Laboratory. And so that's where the matrix, the mat, and the lab comes from for laboratory. It's a high performing language. And so the nice part about this is you can do it for a lot of the modern day uses you need, and it has specific applications that are very important in electrical engineering. We have signal processing, which is one of our concentrations we do at CCLB. There's symbolic, there's control theory, so they heavily use this. And there's also optimization toolboxes. So if you need other types of sources in order to complete your projects, and it's a very nice tool to code in for learning especially. And so the compiled languages, what you guys have is you have two types of programming languages. And so within these languages, for compiled ones, you need to be compiled and linked before results can be seen, such as in C++, Java, BASIC. So you need to actually compile the code. So you need to run it through. While interpreted languages, they're basically executed as soon as they're entered. And so you don't have to wait for the compilation of the program. And some examples of those are Python, we have MATLAB, and those are the most common. So let me go on and let's actually talk a little more about MATLAB's interpreted language. And so MATLAB, the nice part about it is you can see the results pretty easily. So when you type in something, you're able to see it actually get displayed. So the nice part is you don't have to deal with all these like zeros and ones and binary in order to see the result. You see the actual value like in decimals. So that's pretty nice. And it's easy to debug, but it takes a little time to execute. So that's the hard part with this. But MATLAB's pretty good overall. I enjoy it personally more than coding on C and C++ because MATLAB, it's more like you just enter in the equation and it gives you the result. And so let's get started a little with MATLAB. So there's a little functions here. We'll show you on the next page what it looks like. As with any programming language, there's a command window. And so the command window is basically the big part on your screen where you get to see everything. Within the command window, there's like your main window. There's also where you can enter in your variables and run the program and manage any of the software. Then there's a command history window. So that's like where all the history is stored of everything that's happening that you're coding. And then you have a workspace where it can provide information about the variables you use in your program. So that's very helpful when you need to know which ones you're using and which ones you aren't. And another one is the current directory. So that tells you where the files are stored in the specific folder you're working in. And then finally, you'll have a help browser, which is usually like up in the top and you can hit for help if you ever need it. And so let me go on to the next one. And let's get a look at actually what this is, and then we'll actually start coding a little bit. So MATLAB, it looks like this. So you can see your command windows right here. And then you'll also know that you have your home, your plots, your applications. And so a lot of the times when I'm in MATLAB, I look at everything at once. I'm like, okay, here's the folder I'm in. So it will tell me the folder and the specific file I'm running. On the right-hand side, I'm like, here's my workspace. Here's the variables I have in here. And then I'm like, okay, this is where I'm going to write the chunk of my code in. And that's basically it. That's what I look at. So from left to right, I'm like, okay, here's the folder and file I'm working in. Here's where I'm going to code everything. And here's any variables that are stored. So I know. And so you guys know in MATLAB, a lot of the time you'll be working with live scripts. So you can see your results lively instead of using the script feature. So I personally enjoy live scripts, so I'll show you how to use that. It's very easy and user-friendly. Okay, let me switch over to MATLAB because I feel like that's going to be a better intro than just showing you on the screen. So let me leave the screen real quick. So let me exit and let me go over to MATLAB. Okay, so can everyone see my MATLAB screen here? Hopefully you guys can. Just give me a thumbs up or something. Okay, good. And so right here when I open MATLAB, I had the new script feature, new live script. You can also see you can add more new stuff if you want to do Simulink model. You can open a file here. You can save your workspace if you need to. So what we're going to do is very basic today. So when you open up MATLAB, you'll get to this screen and I hit new live script. And I like new live script because I get to see the code and I can also insert what I want to. And so what I'm going to start you guys out with is let's do some variable declarations. And so let's just make a variable called x, like in math, and let's give it equal to 3. Okay, so let's try that out. So when I hit run section, you can see it's going to tell me on the right what I put in here. So I have x and I set it equal to 3. Okay, so that's great. Like I assigned the value 3 to the variable x. That's amazing. So what can we do with that? And so now we can see, let's take the value of x and let's take the former value and add 3 to it. So what this is doing right here is it's taking the previous value for x, which we declared up here as 3, and it's adding 3 to it. So that should be 6. And then it assigns that as the new value of x. So how I like to think of it is the new value is equal to the current value plus what you want to add to it. And so right here, the new value of x is going to be assigned the current value stored in x right now, which we know is 3 plus 3. So that should give us 6 as a new value of x. So when I run this, you can see it tells me the value for x is now 6. So that's great. We know how to define a variable, give it a value, and we know how to add to that value. And so I'm going to show you now how you can actually do characters. So besides integers, you can make characters. And so let's say I want to store the letter B. So I use single quotes for this because a character is a single letter, if you think about it. So that's why single quotes are used for characters. It's just one. And so when I hit run here, you can see it's going to tell me that S is stored and it stores the value B in it. So that's what we've done so far. And now let's do a little mathematics here. So I'm going to have a section break to just show you, and let's do another one. So I'm going to say A is equal to 3, B is equal to 10, and C is equal to 2 times B plus A. And so let's look at this. If we store the value of A, store value of 3 in A, store the value of 10 in B, if we do this, multiplication comes before addition, if you guys remember PEMDAS. So 2 times 10 plus 3, that should give us 23 as the result. When we run it, we see, yep, we got 23 for the value C. Okay, now that we know how to do that, I'm going to introduce some syntax here. See how all these are showing up on the right-hand side? Let's say we don't want that. We only want the last one to show up, so the value for C here. What we do is we put a semicolon at the end, and basically when we put a semicolon at the end of a statement here, it hides it from being displayed. So look here, it hides this from being displayed for the value of A and hides the value B from being displayed here. Okay, now let's talk about comments a little. You can see here up for my comment, I just started it with a % sign, and that's how you make a comment. So you just put here like this is a comment. That's basically how you make one. You just start it with a % sign. And now that we talked about that, let's get into a little how you can do more things than just simple math. And so for good programming practices, we know there's a few keywords you have to watch out for in MATLAB. And the reason I'm bringing these up is because you'll run into them later on when you have to actually do loops and statements. So if statements, while loops, for loops. So I'm going to introduce to you guys the main ones that you'll see in MATLAB. And so these are the key words all the times you'll see. And for us, it's a good way. So break is the first one, and then the next is case, else, if, and then we also have n, for, function, global, if, otherwise, persistent, return, switch, try, while. And so these are just keywords. So you guys know, don't use them for variable names. So when we create variables here, don't use these as the name for the variable because they actually have functions associated with them. We can have loops, as you can see with our if, else, if. And then with our while and for loops, those are the major ones you'll encounter in MATLAB. You also have to watch out for case statements and if the program returns anything. So those are just some key words to watch out for when you're coding in MATLAB. And let's talk now a little about how you can do all the specific functions in MATLAB for your simple mathematic operations. And so I'm going to show you guys addition here. And so for addition, it's going to be basically like 2 plus 3. That's great. Subtraction, pretty simple. Same thing, 2 minus 3. Multiplication, same thing, 2, and then you do an asterisk times 3. Division equals 2 divided by 3. And then we can do exponentiation, which is like 2 to the power of 3. And so you guys know that's how you're able to do all the simple mathematical operations. And so you guys know the order is in PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So that's the order that MATLAB executes it in a function. So say if I had here 2 to the power 3 plus 3, it first does the exponentiation. So it does 2 to the power 3, and then it does the addition. So it goes from left to right for PEMDAS, so you guys know. And when I run this, it should give me all the results stored in those variables. Okay, now that we talked about the order of precedence, what I want to do is I want to tell you guys some functions, because functions basically, let me do a new section here. Functions have an input and an output. So if you guys think of it, some basic functions that you'll run into a lot of the time is the square root function. And so the square root function, it basically looks like this, sqrt, and then you can do like square root 4, something like that. So your variable goes inside the square root. Okay, another good one is nth root. This is a popular one in MATLAB. So the nth root, basically what that means, I'm going to show you guys here because I feel like you need to see it actually to understand it. It means the variable you want in here to the nth root. So like if we wanted to take the square root of 4, n would be 2 and x would be 4. So nth root, in order to do that, you basically, the function is called nth root, and then your x comma n. And then the next one is going to be your exponentiation. And so that's like when you do like e to the power of. And this is a common one, so you guys know. So if you want to do e to the power of x, or e to the power of 10, let's say, what you need to do is you need to write x. So that means e to the power of x here. Okay. Now that we talked about that, absolute value. So the absolute value function, that one is going to be ABS. So that stands for absolute value, and then of x. So that takes the absolute value of x. So the variable you declared for x, like 4, you could make x equal 4 and then do the absolute value 4 would be the result. Okay, now that we talked about that, we can talk about the logarithmic function. And so to do the logarithmic function, you just say log 10 of x. Because just remember base 10, that's usually what's pretty common in here. And so for the logarithmic function, it's log 10 of x. Be careful because natural log function is just log of x. So you guys know natural log, if you recall from your math class, it looks like this, L of n of x. So that's when you just use log of x. The reason we have log 10 is because for normal log functions, when we have like log of x, the base is 10, if you guys recall. So there's like a 10 here for the base, and then it's of x. So that's basically how we have all this right here. The last one I'll introduce is factorial. So that's the other big function you'll have to know. So the factorial function, and what you do is you say factorial of x. And if you recall what a factorial was, it's like if I did 3 factorial, that's equal to 3 times 2 times 1, which is equal to 6. Okay, now that we talked about that, let's go on to the implementation of trig functions, because you'll see these a lot in MATLAB. And so I want to make sure you guys know trig other than just your basic functions. And so for trig functions, there's a very important difference in these that I want to make sure is noted. Oh, let me do new section right here, keep it clear. And I'll make this small. So for your trig functions, make sure this is a comment so it doesn't actually run it. What you can have, there we go, put it at the top. So we can have sine. So sine is very common, and let's do sine of x. That's pretty common. You can do cosine of x. You can do tan of x. And then you have cosine d of x. Probably wondering, what does d mean? D means in degrees. So all of these above are in radians, but the d, if you add that to the end, that means do this in degrees. So if we wanted to do actually like sine of 30 degrees here, that's what we put in here. If we want to do radians, this would be sine of pi divided by 6. So that would be 30 degrees, the equivalent of. And same thing here, because this is in radians, we have to do pi divided by, we could do just pi divided by 4 or something. That should give us 2 rad 2. And then here we could do tan pi divided by 4 as well. And so these are just in radians, so you guys know, without the d at the end, but these are in degrees here with the actual d. Okay. Now that we talked about degrees versus radians, the man, hard to pronounce. Basically the inverse functions. So for the inverse functions, you know, like how you have sine to the -1 of x, how you write that actually in MATLAB is you do that a little differently. You do a sine of x. And so that performs the inverse. So we just put an a in front of it. So that's to carry out the one right above here. And if you want to do the inverse in degrees, like I told you guys, The only difference you have to do here is add a d, and that does it in degrees. So this does the actual inverse function in radians, while this does the inverse function in degrees. Okay, so now that we talked about that, I can just put like a value like pi here and here 30 degrees, something like that. Now that we talked about all those, I can run it if you guys just want to see. I might get an error if I didn't do my trig correctly. Oh, cool. Okay, so we got answers for them. You can see I didn't assign any variables in front to give it to. So you can see it just said like answer equals 0.5, and that's like great and all. So the default variable is just answer. And so it's just assigning this to answer. So if I actually want to give this a value, like say val1, then when I rerun it, it will actually store it under a variable and not just store it under answer. So you can see val1 equals 0.5. So I just didn't assign variable names to these. Okay, A, is it for arc? Yeah, you can think of it as the arc sine. I call them inverse trig functions. You're correct, Keo. Okay, now that we talked about that, let's do another section break. And let's talk about rounding. So if I do round of 3.4, that's going to round to the nearest integer. So it's going to round to 3 when I run it. You can see right here, it went to 3. However, if I do fix a 3.4, that's going to round, or 3.6. Would that round up to 4 like normal? No, it doesn't. Look, it rounds to 3. So fix, this rounds towards 0, while round just rounds to the nearest integer. Fix rounds towards 0. So if you think on a number line, basically here, if we have 0 right here, and we have 3.6, and 3.6 we know is in between 3 and 4. But if it rounds towards 0, it's going to round in this direction. So it's going to go to 3. Okay, now that we talked about that, we also have seal, and that rounds towards positive infinity. So if we do seal like 2.2 or something, that should go to 3. Yep. Okay, so this rounds towards infinity. And my next one, I'm going to do floor of 3.7. And floor, it basically rounds to negative infinity. And so you'll see it should go to 3 when I hit round. Yep, 3. And so that's pretty nice. We can see how the rounding works. So when you round, just use the normal one. It rounds to the nearest integer. Fix rounds towards 0. And I just think of it as a fixed point, like, you know, it's fixed, the number line. So it's fixed at 0. Seal, like reach for the ceiling towards positive infinity. And floor means like falling to the floor. So round to negative infinity, going down. And so now that we talked about that, let's talk a little about how we can actually use clear functions to keep our program looking nice. And so what I first want to do is I want to show you how, if you would write, so let me do section break here, CLC, what does that do? And you see when I wrote it, it says clear command window. So that is what it does. It clears the command window. And you're probably wondering, what's the command window here? Well, when I run it, you see like, oh, nothing was cleared. That's weird. Like, was something supposed to happen? Well, if you remember, the command window, what we have it as is it's actually, let me show you guys. If I did x equals 3 here and just run it in the normal script, where's my run button? Let me. Okay, so right here in the normal script, you can see when I type in x equals 3. So if I type actually in here to CLC, it clears the entire screen. So this is just in the actual scripting here. So if I do like x equals 5 and then like y equals 9, you can see this can get very disorganized real quick. So if you just want to clear everything off the screen, you type in CLC. Okay, now that we talked about that, I want to talk about clear. Clear clears basically all the variables from memory. And so you can see when I hit clear here, what's going to happen is when I run that, any variables stored in the program that I'm going to call, let's say, I want to do y equals x plus 7. And you can see I defined x up here as 3. And because I typed in clear here, when I hit y equals x plus 7, let's see, it's loading and it doesn't recognize x anymore because I cleared it from memory here. And so it doesn't know what value I stored in for x because it cleared this from memory, anything before. So that's why. So clear basically clears all the variables from memory that you have stored above. Okay, now that we talked about that, we can then talk about our next part, which is let's do an exercise because I feel like we need to practice a little. So for our exercise, so I'm going to do a comment for this. For our exercise, we want to calculate the area of a circle. Too much from 211. Okay, so to calculate the area of a circle, remember, it's just the equation pi equals the radius squared. And so area equals, pi times the radius squared. And so what we do here is we would start out. So let's say we want the user to enter in the radius. So this will show us two types of things with our exercise. So for the radius, it equals the input from the user. So I'm going to just say for the input, what is the radius you want for the circle? And so now that I asked the user what radius they want in the circle, I'm going to talk about the actual area equals. So what the user inputs is stored in this variable radius. So what I'm going to do is I'm going to do pi, which is a constant, times the radius squared. And that should give me the actual result. So when I ask the user up here, what is the radius for the circle for the user input, that's going to store it in the radius. Now I'm going to do area. So make a new variable called area. That's going to be equal to our constant for pi times the radius that the user inputted squared. Okay, and I'm going to display the area for the circle's radius entered. Oh, oops, sorry. For the radius of entered was, and then what I'm going to do is I'm going to leave a space here because then I have to hit display and then do the actual area here. So display area. And when I run that, you'll see what is the radius you want for the circle. I'm going to put in 3 here. And when I put in 3 into the workspace, it told me the area for the radius entered was 28.2743. And let's see if that matches up. So when I went to pi times the radius entered we did was 3 squared on my calculator, it gives me 28.2743. And so it displays that value here. And so that's good to know and everything. Now we know how to actually ask the user a question by using user input. So this input function here, and we know how to display that onto the screen for the user. Okay, now that we talked about that, we're going to get a little into our next one. So I'm going to just do a little brief intro on functions just so you guys are exposed to it, because you'll see these a lot in 202. So for a function, it's going to have output variables, and then it's going to have your function name, and then the input variables. So this is the format. And so function is a keyword here. You put your output variables that you want to be returned by the program in these block brackets, and then you set it equal to whatever name you want to give to the function. And you put your input variables in parentheses. And so let's create a function. So for a function, what I'm going to want to do is I want to do y equals the square root of a squared plus b squared. Let's do something simple. So this is the function we want to implement because y is a function of a and b. And so what we're going to do here is for a function, I'm going to give it function v is equal to, y is equal to, and then what I want is I'm going to call it the square root for two variables. And within it, you can tell we're going to have two inputs in here. We're going to have A and B. And so I can just say A, B. And what I can do right now is I'm going to do the function body here. So we declared our function, what it's going to look like. So within the function body, the actual result is going to be equal to, so I'm just creating a variable called result, the square root of a squared plus b squared. So that's within the body of my function, and I don't want that to be displayed on the screen, so I put a semicolon here. And now that I did that, what I'm going to do is I'm going to end the function. So that's where we have a keyword for the function here. And what I'm going to do now for my program is I'm going to set values for A and B, and then I'm going to run the function. So my value for A, I'm just going to put in here like A is equal to 2, and then my value for B is going to be B equals 3, and then I can say Y equals the square root of two variables. And the two variables here that I'm going to plug in are A and B here that I declared. And so, oh, sorry, I just zoomed out. And so now that it's going to plug this into the function up here. So it's going to plug in my values I stored for A and B right here. A as 2 and B as 3. And I think it's underlining because I declared A up here. So let me just delete that real quick. So when it runs this, what's going to happen is it's just going to run that specific section. So you guys know. So when we actually run this, we should expect that it should be 2 squared, which is 4, plus 3 squared, which is 9. So 9 plus 4, we should get 13 and take the square root of 13. So what we should be expecting is 3.6 when we actually run this. And so I'm going to clear any variable, clear anything that came before just so it doesn't show up. Okay. It looks like function definitions in this script must appear at the end of the file. Okay, so let me just put this at the end of the file then, like it wants. And let me run it. Okay. So when I hit run section here, it says output argument y not assigned during call y to square root two variables a, b. So this is a good practice of trying to find out where the error is here. So we have our function declared a and b. And so, oh, I noticed I didn't assign y to, I just gave another variable name. So then our output, I need to assign it to something. So the output's going to equal the square root of this. So let me retry this now, and let's see if that will fix the error. Oh, sorry. It's going for the whole program. So let me delete this one we did up here for exercise. Okay, let me run this again. And when I ran that section, I got y is equal to 3.6056. And so that's how I was able to, right here, I had to put the function at the end of the statement. So I have the function keyword here, the output variable, and because it was single, we didn't need the brackets, but if you had more than one output, you do use the brackets. It's fine if you have one variable without it, but if you have more than one, use them. But you can also use them for one variable. It's totally fine. And then you did the name for the function you called and the input variables. And then I set the output equal to that inner mathematical operation. And then I ended the function. And here I stored my values for A, B, and I put them in this function to run it. It went down here, calculated it, and set it as my output. And that's how I got the y equals 3.605 here. And now that I know that, we talked about functions, which is a big thing. Basically, that's a lot of what you'll do in MATLAB. And the last thing I'm going to show you guys is just how you can export it to PDF. So if you go to save here and hit export to PDF, a lot of the times that will help you for homework assignments. And that's basically everything I want to cover for the main overview of MATLAB. And if there's any other questions, feel free to bring them up. We're going to pause there, and that should be it. Thank you all for coming. Hopefully that helped.
Yeah, I just have one question.
Mhm.
So if you, how do you separate like the function from the clear and the variables you're putting in for the already defined function?
Oh, this one right here, how did I create a separate block from like this block here?
Yes.
Okay, there's a nice feature here. So see, let's say I want to create a break in between here, fix and seal, okay? So what I do is I hit this up here. It's called section break. You see that?
Okay.
Click it and see how a break occurred between the two. So what you do is you can hit section break on all these, and it will start dividing your work into sections. So you can run that specific section, and then you can go through step by step in that section to see where the error is occurring. And you can run the next line and then run the next line.
Cool. Thank you.
Okay, I think that's it. So I'll just stop the